Engine control systems. Engine performance is critical for vehicle efficiency, fuel economy, and overall engine longevity. The engine control systems are responsible for monitoring and managing key components that directly impact engine performance. These include the fuel injection system, ignition system, sensors, and the engine control module. Understanding how each of these components works, how they interact, and how to diagnose issues is key to maintaining optimal engine performance. This lesson will dive into each of these systems, providing foundational knowledge to help you effectively diagnose and troubleshoot engine performance problems. Fuel injection systems. Fuel injection is a critical component in modern engines, replacing carburetors to deliver precise amounts of fuel to the engine's cylinders. The fuel injection system works in tandem with the engine control module to optimize fuel delivery based on various engine conditions. Function of fuel injection. Fuel injection systems are responsible for mixing fuel with air in precise amounts to allow for efficient combustion. The engine's ECM controls fuel delivery based on inputs from various sensors. Types of fuel injection systems. Single-point fuel injection. Fuel is injected into the intake manifold near the throttle body, where it mixes with air before entering the cylinders. Multi-point fuel injection. Each cylinder has its own fuel injector that directly injects fuel into the intake manifold, providing more precise fuel control. Direct injection. Fuel is injected directly into the combustion chamber, allowing for more efficient combustion and better fuel economy. Key components of fuel injection systems. Fuel injectors. The injectors are responsible for delivering fuel to the engine in a precise spray pattern. These are controlled by the ECM, which regulates the timing and duration of the injection. Fuel pump. The fuel pump supplies fuel from the fuel tank to the fuel injectors under pressure. Fuel pressure regulator. This component maintains the fuel pressure within the system to ensure consistent fuel delivery. Fuel filter. The fuel filter removes impurities from the fuel to prevent clogging of the fuel injectors. Diagnosing fuel injection system issues. Symptom: engine misfire or rough idle. Possible causes: clogged or faulty fuel injectors, low fuel pressure, faulty fuel pump. Diagnosis: perform a fuel pressure test to check for proper fuel delivery. Inspect fuel injectors for clogging and use a Noid light to test injector operation. Symptom: poor fuel economy. Possible causes: faulty fuel pressure regulator, malfunctioning sensors, or improper fuel mixture. Diagnosis: check the oxygen sensors, mass airflow sensor, and fuel pressure regulator to ensure the engine is receiving the correct fuel-air ratio. Ignition systems. The ignition system provides the spark necessary to ignite the fuel-air mixture in the combustion chamber. The system includes components such as spark plugs, ignition coils, and the ignition control module. Function of the ignition system. The ignition system ensures that the engine's spark plugs fire at the correct time to initiate combustion. It must provide enough energy to create a spark that can ignite the air-fuel mixture, ensuring that the engine runs smoothly. Key components of the ignition system. Ignition coil converts low voltage from the battery into high voltage that is sent to the spark plugs. Distributor. In older systems, the distributor directs high voltage to the correct spark plug. In modern systems, this function is often replaced by individual coils for each cylinder. Spark plugs. Spark plugs create the spark that ignites the air-fuel mixture in the engine cylinders. Ignition control module. The control module regulates the timing of spark generation based on inputs from sensors such as the crankshaft position sensor. Diagnosing ignition system issues. Symptom: engine misfire. Possible causes: faulty spark plugs, malfunctioning ignition coils, or a bad ignition control module. Diagnosis: inspect spark plugs for wear or carbon buildup. Use a spark tester to check for spark at the plug. Test ignition coils and the ignition control module for proper function. Symptom: hard starting or no start. Possible causes: weak spark, faulty ignition coil, or broken timing chain. Diagnosis: Test the ignition coil for continuity using an ohm meter. Check the timing with a timing light and inspect the timing chain for wear. Sensors and ECM. The engine control module is the brain of the engine, using data from various sensors to control the operation of the fuel injection and ignition systems. The sensors collect real-time data on engine performance, which the ECM uses to make adjustments that optimize fuel efficiency, performance, and emissions. Types of sensors in the engine control system. Crankshaft position sensor monitors the position and speed of the crankshaft to determine the timing of fuel injection and spark. Camshaft position sensor works in conjunction with the crankshaft position sensor to determine the position of the camshaft, which helps with fuel and ignition timing. Oxygen sensors monitor the exhaust gases to ensure the air-fuel ratio is optimal for combustion. They send data to the ECM to adjust fuel delivery. Mass airflow sensor measures the amount of air entering the engine to help the ECM calculate the correct amount of fuel for combustion. Coolant temperature sensor monitors engine temperature and helps the ECM regulate fuel injection timing and air-fuel mixture. Engine control module. The ECM processes data from all of the sensors and controls components like the fuel injectors, ignition system, and exhaust system. How it works. The ECM adjusts various parameters to ensure optimal engine performance, including fuel mixture, ignition timing, and idle speed. Diagnostics. The ECM stores diagnostic trouble codes when it detects malfunctions. These codes can be retrieved using an OBD2 scanner, which helps technicians pinpoint problems in the engine control system. Diagnosing sensor and ECM issues. Symptom: engine running rich or lean. Possible causes: faulty oxygen sensor, mass airflow sensor, or coolant temperature sensor. Diagnosis: use a scan tool to retrieve DTCs from the ECM and check for sensor malfunctions. Perform voltage tests on the sensors to ensure proper operation. Symptom: engine stalling or poor idle. Possible causes: malfunctioning crankshaft position sensor or camshaft position sensor. Diagnosis: inspect and test the sensors using a multimeter to check for proper signal output. Verify the ECM is receiving accurate data from these sensors. Summary of engine control systems. Here's a table showing the summary of engine control systems. You can pause the video if you want more time to review the table. Conclusion and recap. In this lesson, we explored engine control systems, including the operation of fuel injection, ignition, and sensors, and the role of the engine control module. We also discussed common issues related to these systems and diagnostic steps to resolve them. A strong understanding of these systems is essential for troubleshooting engine performance issues and is critical for ASE certification test A8.